Okay, engineers, let's continue with the partial fraction examples. And here we have the case of repeated roots. So what are the roots? S1 is equal to 1, S2 is equal to 1. It is repeated because you have the square here, and the S3 is equal to minus 2. So those are the three roots, because the denominator is power 3. So that means that you should have 3 roots, and that means 3 partial fractions. Okay, so the partial fraction will be something like this. A over S minus 1 to the power of 1 plus B over S minus 1 squared. Okay, with these two partial fractions we cover these two roots. Now again, we cannot use here 1 to cover the second root because it will be the same fraction, so there is no difference between this and this. So the difference is, and the repetition is on the square there. Okay, plus C over S plus 2. Okay, so now the task is to find the values of A, B, and C. Okay, A, B, and C. From the previous example, we saw the Heaviside method to find the values of A, B, and C. We can use that method, but only partially, because we can use that method to find the value of the B, of the C. We can find the value of C, and we can find the value of B, but we cannot find the value of A. Okay, so let's use it for the value of C. So the method that we saw is the value of C is equal to, for this partial fraction, is actually this number, but you remove the S plus 2. Okay, so it's going to be 2S squared plus S plus 3 over S minus 1 squared. Okay, so here now you replace the value of the root of that value of C, which is S equal to minus 2. So let's replace it. It's going to be 2 minus 2 squared plus minus 2 plus 3 divided by minus 2 minus 1 squared. So in the denominator it's going to be 9, because it's going to be minus 3 squared, 9 positive, and in the numerator this number is going to become 4 times 2 is going to be 8 positive, and then minus 2 and 3 is going to become plus 1. So this is actually 1. So the value of C is equal to just 1. Okay, we got the value of C. Now let's calculate the value of B. For the value of C, we use the root S3 equal to minus 2. Now if we want to use S equal to 1, which is the other root, S1 equal to 1, to find the values, we can only find it for the value of B. Why? Because if you look at this fraction, if you replace 2S squared plus S plus 3 over, because it's the value of B, is going to be S minus 1 squared, so you eliminate that part, S plus 2. But you cannot do that for the value of A, so that's where the Heaviside method doesn't work for these repeated roots. You can use it only to find the highest one, the highest power. So we can only use it for the value of B. Okay, so let's use it. S equal to 1. So let's replace the value of 1. 2 times 1 squared plus 1 plus 3 divided by 1 plus 2. So this is going to be equal, in the denominator is 3. And in the numerator is going to be 2 plus 1, 3 plus 3, 6. So 6 divided by 3, B happens to be just 2. So we found the value of B and C, but for the A we cannot use the Heaviside method. So what we have to do is to make the common denominator and find the value of A. So if you do the common denominator here, is going to be S minus 1 squared times S plus 2. So the common denominator is, this is the common denominator of this. Now it's not going to be S minus 1 to the power of 3, because that is not exactly the original fraction. So it's actually 2, right? A square, like the original fraction, sorry. So this divided by this is going to be A times s minus 1 times s plus 2. And now, this is making the division of this, divided by this, so s minus 1 cancels, but only 1. So that remaining times the a and s plus 2. Now for this divided by this, the s minus 1 square cancels. So the only thing left is b s plus 2. And then plus the c. This divided by this, the s plus 2 cancels. The only thing left is the value of c times s minus 1 squared. Now, because you already know what are the values of b and c and b, let's make the replacement. The value of b happens to be 2 and the value of c happens to be 1. Okay, because you already know these two values from the previous examples, the only thing that you need to calculate is the value of a. Okay, now because this fraction is already the same as this, 2s squared plus s plus 3 divided by s minus 1 squared times s plus 2. So as you can see, the denominator is already the same. The only thing that happens, that needs to be equal, is the numerator. So the numerator is a s minus 1 s plus 2, and then here plus 2s plus 4 if we do the multiplications, plus here if we do the binomial. You can do it or you cannot do it. It's up to you. S squared minus 2s plus 1, and that is equal to 2s squared plus s plus 3. So the only thing to calculate is the value of a. At this point, what you can do, engineers, is just give any value of s. Any value of s, but you cannot repeat the values previously. You cannot choose s equal to 1, you cannot choose s equal to minus 2. But you can choose any number so that you replace that value of s and calculate the value of a. My recommendation is to pick up an easy value. So you can choose actually 1 million if you like, but that is going to be very difficult for the calculations, and the result is the same. So I'm going to choose one simple value, and I'm going to choose 0. 0 is not repeated in the previous values. So, and if you choose the previous values, you are going to get c and b, which is something that you already have. So let's use the value of s equal to 0. So if you replace it, it's going to be a times 1, minus 1 here, times 2, here, 0 plus 4, 0, 0 plus 1, equal to here is going to be 0, here 0, 0, and the only thing left is 3. So here the value of a is minus 2a equal to 3 minus 5, which is minus 2 in this case. So the value of a happens to be minus 2 over minus 2, which is just 1. Okay, with that we have already calculated the value of a. Now this is the cases when you have repeated roots. You can use, again, you can use the Heaviside method, but you can only calculate one of the values. The rest you have to make the common denominator and replace some values so that you can find the value of a in this case. So the partial fractions, the result of the partial fractions are like this. A is 1 over s minus 1 plus the value of b. b is 2 over s minus 1 squared plus the value of c, which is just 1 over s plus 2. Now, if this is an inverse transform, then assuming that this is that the problem asks you for the Laplace inverse, then the Laplace inverse of this is just exponential of t plus 2. The 2 goes outside of the Laplace inverse. The Laplace inverse of this, if you check your formulas of the Laplace inverse, is going to be t exponential of t, plus the Laplace inverse of this is going to be exponential minus 2t. And this is the Laplace inverse of the original fraction, 2s squared plus s plus 3 divided by s minus 1 squared, s plus 2. So this is the result of the Laplace inverse of that fraction. And again, as you can see here, you don't have a formula that fits in this fraction. What you have to do is make partial fractions so that you can apply the formulas for each one of them and get the Laplace inverse. So this is an example of the repeated roots. On the next video we are going to see what to do when you have imaginary roots. Okay?